Okay, so we're posed with a question of what volume of 0.128 molar HCl is needed to neutralize 2.87 grams of magnesium hydroxide. In these types of problems, we see something in a technique called titrations. And if you'll remember way back with titrations, I think we kind of discussed this just a little bit when we were talking about solutions, but this talks about dilutions. Like if you're measuring concentration, the only thing that you're diluting is going to be its volume. You're not going to be changing the number of moles. That stays the same. And so that's the idea behind these types of problems. Okay, so let's go ahead with the setup. First thing we need to do is you need to write a balanced chemical equation. And so we have HCl reacts with magnesium hydroxide, and this is a neutralization reaction. So our products are going to be a salt and water. So it's magnesium, chloride, and I'm going to erase this. Just give me some space, and I'll put it back on there. Okay? Okay, so plus water. Move it up. B1 equals B2. Okay. And so then I'm going to start filling in my information. They give me a 0.128 molar solution. And remember that when you see your big M, that is moles of solute divided by liters of solution. Just please don't forget that. Yesterday we made the connection to density, which was grams per liter, or grams per milliliter, or grams per cubic centimeter. Okay, and then I think I get 2.87 grams of magnesium hydroxide. Okay, so I want to always go back and double check to make sure my equations are balanced. And so I need a 2 in front of the HCl because of the 2 on the chlorine in the product, and I need a 2 on the water because of the 2 hydrogen plus 2 hydrogen to give me 4. And this should be a balanced chemical equation. So class, is this correct? Yes. Okay, cool. All right, so something should have already stood out to you. A lot of times one of the challenges that we have with working stoichiometry or stoichiometric calculations is where do I begin? And anytime you see grams, where should you go? To moles. So let's go ahead and do that. Let's go ahead and say our 2.87 grams of magnesium hydroxide. And let's go ahead and get that to moles, because once you're in moles, you can go anywhere. And I believe that the molar mass of magnesium hydroxide is 58.301. I'm hoping that I'm in the neighborhood of where you guys are in your calculations. And if I'm not, somebody please tell me. 301 grams in 1 mole. Okay. All right, so 2.87 divided by 58.301, and I got 0.04923 moles. Now, I'm using lots of numbers here. I'm not going to be worried about my significant digits, because remember that every time you round up, you're going to throw your number off just a little bit more. So I'm just trying to make it as accurate as I possibly can, and so I won't do any rounding until the very, very end. So now I'm in moles of magnesium hydroxide, and I can go to moles of hydrochloric acid that's in the equation. So for every 1 mole of magnesium hydroxide, okay, I have 2 moles of HCl. Okay, so you've seen this for the last couple of days. You calculated the molar mass to get to moles, and you've looked to the balanced chemical equation to go from moles of one substance to get to moles of another. And the answer that I got for this one was 0.09845 moles of HCl. Okay, so I'm looking around the room, looking to see if I'm anywhere close. My calculations, always double check my math, because we know what happened yesterday. Okay. Okay, so now you're like, well, that's fine. I mean, I got to this part, and I got to this point, and I understand, but then all of a sudden it's asking me for volume, and now I don't know what to do. Okay, so this is where you're letting the units kind of give you some inspiration. So I'm going to take my molarity equation. I'm gonna pull it down here. So they told me that the concentration of my acid was 0.128 moles per liter, or it has a molarity of 0.128. And I'm going to set up my, I think we call this a proportion. Well, we can, but when you can write it either way, right? Because you've got your number of moles, right? Divided by X, right? Right? Because whatever this number is, these divided should give me that answer, right? Yeah, isn't that right? Right? So you can, either way is fine. You can write it either way, it's fine. It's okay, you're good. Okay? So of course we're gonna solve for X. And so here's where I need to pay attention. And you multiply both sides of your equation by X, and then you divide both sides of your equation by molarity. So, and I'm not going to bore you with all that. So I'm just going to rewrite the problem, the setup over here, so you can see it. You guys have a way stronger understanding of math than I do. So, all right, moles per liter. Let me get out of the way so everybody can see the board because I'm having to write at the bottom. So. All right, so does everybody see what I did? So algebraically, just multiplying both sides of your equation because you're trying to isolate your X. So you multiply both sides, and then I'm going to have to divide by my molarity. Okay? So, good so far? Now when I divide these numbers, let's see, I think I got something like... Oh, 0.7692 liters. And so let me double check looking around the room for so everybody's square, so my math is square. Sometimes I just make up random numbers. Okay, and then of course if they want us to convert this to milliliters, we would have to multiply times 1,000. So that would give us 769.2 milliliters. Okay, but the problem didn't ask for that. It just said volume, so I'm going to leave this in liters. Okay. All right, so that is our first titration calculation. And here in just a bit, we'll do a couple more.